Hi, the purpose of this video is to show you the idea of composite functions. Composite functions simply means the process of merging two or more functions. For instance, we have two functions which are f and g. Function f can be described as f4 to input, and function g can be described as square the input. After we feed x into function f, the output is x plus 4, and the output from x here will become the input for g. So square the input means square x plus 4, so the output here will be the square of x plus 4. This whole process is called the composition of functions, and mathematically it can be written as g f x equals to x plus 4 squared. And all students must take notes that during the process, function f comes first, then followed by function g. But when we write the composite function, we should write the function that comes later, which is g, and then followed by the functions that come earlier, which is f. So you can see here the composite functions is g f x equals to x plus 4 squared. If the composite function is written differently, for example f gx, then it refers to a different process, which means the input will be fed into function g first. Function g is square the input, so the output here will be the square of x, and the square of x will become the input for function f, which can be described as f4 to input. So now when we add 4 to the input x squared, the output now become x squared plus 4. So fgx is equals to x squared plus 4. Even though both gfx and fgx are composed of function g and f, but because of the sequence, they end up with different composite functions. So in composite functions, it is very important and critical for us to identify the sequence, which means which come first and which come later, and how to represent them mathematically. By now, all students should be able to interpret the notation of composite function. For instance, when we see this f gx This means a composite function where x is fed into x is fed into g, then followed by f. Let's say hkx. This composite function means x is fed into function k, then followed by function h, and one more, g k x. Let's change the input. G k y simply means y is fed into k, then followed by g. In diagram, this composite function can be represented by k, then followed by g, and this is g k y. For hkx, it can be represented by x fed into k, then followed by h, and the output is h k x. And for fgx, it means x fed into function g, then followed by function f, and the output is fgx. Sometimes it is possible to have more than two simpler functions to be merged into a single one. For example, g k x. This means x is fed into k, then g, and another g. In diagram, it means that x fed into k, then followed by g and another g, and the output is g k x. Right now, all students should have understood the idea and the notation of composite function. So, let us learn how to form composite functions. For instance, we have two functions where function j such that x is mapped onto x minus 2 over 4, and function k such that x is mapped onto 4x. And now we need to find j k x. So this means we feed x into k and then followed by j. How are we going to form this composite function? It's very simple. J kx can be written as J kx, where this notation simply means kx is the input for function j. What is kx? Kx is equals to 4x. So treat this as the input and we fit kx into jx, which means now we need to apply x as 4x. So this is equals to 4x minus 2 over 4, and it's also equals to 4x over 4, which is equals to x minus 2 over 4, which is 1 over 2. So j kx is equals to x minus 1 over 2. B. Forming kjx. Same as the previous example, kjx can be written as k jx, and this simply means jx is the input for function k. And what is jx? Jx x minus 2 over 4. So we need to squeeze the whole equation here into x. So this is equal to 4, and we squeeze x minus 2 over 4. As the result, this is equals to x minus 2. So kjx is equals to x minus 2. And from here we can see that jkx is different from kjx. And so this is how we form composite functions. Firstly, we rewrite the composite function as this or this. Then we squeeze the function at the back into the x of the first function. By simplifying the equation, we should be able to find the composite function. Now, let me show you more examples to ensure that you really understand the way and the steps to form composite functions. The functions that we are going to deal with are function g such that x is mapped onto 4x plus 4 over 5, and function h such that x is mapped onto negative 1/3 times negative x plus 5. We need to evaluate g h negative 4. In order to find the value of gh negative 4, firstly we have to rewrite gh negative 4 as g h negative 4. This means h negative 4 will be the input for g. So it means that we first need to evaluate the value of h negative 4. So h negative 4 is equals to negative 1 over 3 times negative x. So the input is negative 4 plus 5, and this is equals to negative 1 over 3 times 4 plus 9, which is 4 plus 5, not 9, 4 plus 5, so it is equals to 9. When I simplify this, h negative 4 is equals to negative 3. So now I'm going to squeeze the whole thing here into function g. So this is equals to g negative 3, because h negative 4 is negative 3, and thus is equals to 4 times the input here now is negative 3 plus 4 over 5. So we have negative 12 plus 4 over 5, and thus it is equals to negative 8 over 5. So composite evaluate composite function gh negative 4 will give us negative 8 over 5. This means when negative 4 is fed into function h, the output is negative 3, and when negative 3 is fed into function g, the output is negative 8 over 5. So the whole process here can be described as gh negative 4 equals to negative 8 over 5.